Hello. Yes. We welcome you back to PSSB, Physical Sciences, Silver Bullet, and it's me, Richard, here. Yes, today we are starting the reactions of organic compounds, and we are looking at this question now. What does the question say? It says that alkanes undergo combustion, which is oxidation, cracking, substitution, among other reactions. And then the question A comes saying, using molecular formula, write a balanced equation for complete combustion of 1. Butane, 2. Pentane. So there we are. How do you go about this? Okay, let us look at the first one. The first one is butane. Okay, and they are saying that we're using molecular formula. Okay, what's the molecular formula of butane? Butane, it is C4H10. And it is complete combustion, so we are adding oxygen to give us the products. So what are the products of combustion? For complete combustion, the products are carbon dioxide and water. While for incomplete combustion, it is carbon monoxide and water. But the question says complete combustion, so the products are clearly known. It's going to be carbon dioxide and water. And they said it has to be balanced. So how do we go about this? Okay, we are going to use this kind of approach for balancing. It might not be common to you, but I believe it's easier than all other methods, some of which requires you to cram. Okay, how do you do this? You have 4 carbon here, so there are 4 carbon atoms here. So what do? You make this one 4 to balance that. Okay, and you have 10 hydrogen here. So how do you make this one 10? You put 5. Okay, that's the first approach we do. Then what do? Your carbon is balanced, hydrogen is balanced. So what is not balanced is oxygen. How many oxygen do I have here? It is 4 times 2, which is 8. And how many oxygen do I have here? It is 5. So 8 plus 5, you get 13. The question is, how do we make this one 13? You say it's going to be 13 over 2 because of this 2. Because 13 over 2 times 2, you get 13. So there we are. But you have to remember that we are not supposed to use fractions. So what do under this circumstance? You multiply throughout by 2 to take out the fraction. So what we are going to get in this case is going to be 2 C4H10. This is 13, giving you 8 plus 10 water. Okay, that is that for butane. So then comes our pentane. How do we go about that? Okay, pentane, the molecular formula is C5H12. Remember, the general formula is CnH2n plus 2. Okay, we are adding oxygen and it is complete combustion. What are the products in this case? The products are carbon dioxide and water. And what do we do under this circumstance? We balance carbon. Carbon is 5, so what do? You make this one 5. And the hydrogen is 12. How do you make this one 12? By having a 6 there. Okay. Then what do you have this side? What we have this side is 5 times 2, which is 10, plus 6, giving you 16. Then this side will have 16 oxygen, the side of the product. How do you make this oxygen 16? It's going to be 16 divided by these 2. And what do you get? You get 8. So when you insert 8 here, it's going to be 8 times 2, which is 16, which will be equal to the other side. So our equation is balanced. Then comes this question. It says, give one practical application of the combustion of alkanes. Okay. Yes. Where do we see combustion or burning of alkanes taking place? Okay, here you need to know that most of our fossil fuels are alkanes. So every time we use fossil fuel, like when we are cooking using gas, or when you are driving a car, the reaction taking place there is typically combustion. So what do we say here? 1, cooking using gas or gases. Fossil fuel gases. Or another area where we see combustion of alkane taking place is running of car engines. The fuel which we use in our car, in our motor vehicles, is usually fossil fuels or hydrocarbons. And with that, would like to thank you for your time. The channel is PSSB, Physical Sciences Silver Bullet, and it's me, Richard, here. Yeah, don't forget to subscribe, to like, to share, to comment. Yeah, we are simply the best. Bye bye.